All right, we got a missing angle in the interior of a polygon here. So let me just count the sides. We got 1, 2, 3, 4, 5, 6, 7 sides here. Now, if you don't remember, to find what the interior angles of any polygon are supposed to add up to, it's your number of sides minus 2 times 180 degrees. So since we've got 7 sides here, that's what the n would be. So 7 minus 2 is going to have us doing 5 times 180. Whoops. Sorry guys, let me pull the calculator back up here. 5 times 180, that'll be the inside total, which is 900 here. Okay, so of the 7 angles, we have 6 of them. So I know it's got to add up to 900. So we're just going to subtract each one that they've already got there. We got 136, 133, 119, 126, 127, and 129. So let's subtract all those there. And the leftover should be 130. So that's your x. All right, 58, classified the triangle by sides and angles. All right, automatically here we have 2 sides marked the same, so we've got an isosceles triangle by the sides. And this is 70, this is 70. If it's an isosceles triangle, that would force this angle to be just 40. Every single one of those angles is less than 90, so this would be called isosceles, and it would be called acute based on the angles of the triangle. The base angles of an isosceles triangle are 4 times larger than the measure of the vertex angle. Okay, so the 2 base angles are the same in an isosceles triangle, and it says it's 4 times as large as the vertex angle. So let me call the vertex angle x. If I'm 4 times as large, that would be 4x here and 4x here, because the 2 base angles are the same. So let's find our angle measures here. We know the inside angles of a triangle add up to 180, so I got 4 and 4 plus another 1 would be 9x equals 180. Inside angles of a triangle there. All right, if you divide both sides by 9, that'll be 20. So your vertex angle here should be 20. And then if we plug in 20, 4 times 20 will make both of our base angles 80 degrees. And you can check that adds up to 180 here real quick. 80 and 80, 160. Plus 20. All right, so 60, this is the last unit we just got done with, so we're matching here. Circumcenter is the perpendicular bisectors, so that's going to go with letter D. Incenter is the angle bisectors, that's going with C. Orthocenter is the altitudes, that's going with B. And centroid is the medians, so that's going with A when you're matching there. Find the value of x. The whole thing here is 16, so I'm going to add those 2 segments together. This is the segment addition postulate. 3x and 5x will give us 8x. 2 minus 10 is negative 8. That's supposed to add up to the entire segment, which is 16. I'm going to add 8 to both sides there, so we would get 24 equal to 8x, and then x is going to be 3. 62, identify the hypothesis and conclusion of the conditional statement. So the hypothesis is after if and up to your comma here. So if you're not from Indiana, so the hypothesis would be you are not from Indiana. The conclusion is what follows the then. It says then you are not a Hoosier. That would be the conclusion right there, that you are not a Hoosier. So hypothesis, you are not from Indiana. Conclusion, you are not a Hoosier. 63, let's slide this up here a little bit so we can see. Let's see. We're supposed to find the measure of TQM, which will be this angle here. We're going to need to find x to be able to do this. These 2 angles together, you can see, form a right angle. So I'm going to add these 2 together, just combine like terms. 3 and 2 is going to give us 5x's. 4 minus 9 is minus 5, and I can see from the symbol here, this is together going to form a right angle. So if I add 5 to both sides there, we're going to get 5x is equal to 95, and if I divide both sides by 5, x is going to be 19. Now, not the answer to my question. Here's my question, TQM, so we're going to have to plug that back in. Okay, so if I do that, let me just pull up my handy-dandy calculator here. And 2 times 19 is going to give us 38, And from that, we want to subtract the 9 in that expression. So the angle they're asking here for is going to be 29 degrees. 64, the length of one side of a regular pentagon is 4 feet. What is the perimeter of the pentagon? Okay, if you remember, regular means all the sides are the same. So let me just sketch a tiny, this is not drawn to scale at all, but 5-sided figure is what a pentagon is. Regular means each one of the sides is the same length. So every side there would be 4. So the perimeter should just be the 5 sides times the length of 4 each. So 20 feet would be your perimeter. And we have one more lovely problem at the bottom, and then we're done. Okay, let's mark up what we got going on in the diagram. AD is right here, is parallel to BC, good deal. And AB is parallel to DC. So the left and right are parallel, top and bottom are parallel. So my opening statement here is going to be that was given information. Okay, let's see what they're leading us through here. ADB would be this angle here, and CBD would be this angle here. Also stated here, ABD, which would be this angle here, and CDB, which would be this angle here. How do I know those are congruent? Well, what we have going on here, if you look at the two sides, the AD and BC, this would be a transversal. You have this set of alternate interior angles. If you look at AB and DC, also parallel, the same line as the transversal, but here I get the two angles that I put the double curves on. So both of these, reasoning would be that these are alternate interior angles. So I'm just going to abbreviate that. Let's see. DB is congruent to DB. Well, anything when it's equal to itself, that's your reflexive property. And let's see, how do I know these triangles are going to be congruent to each other? So just for 1 second, I'm going to just pull this apart. I think sometimes the reasoning is a little trickier to see when the triangles are touching each other in this format where it's kind of a little parallelogram is what's going on here. But once you pull them apart, it's maybe a little easier to see. You have an angle, a side, and an angle. So that's going to be my reasoning. And if the triangles are congruent, it automatically forces all the parts, angles, segments, whatever we didn't know before. If we know the two triangles are congruent, it forces all the corresponding parts to be congruent. So even though we didn't know this, AB would be this segment right here, CD would be this segment right here, and then AD, 1, 2, 3 here, and 1, 2, 3 here. This is called corresponding parts of congruent triangles are congruent, and we abbreviate that with CPCTC.